Week's special episode from AVADirect. Today, we're going to be testing whether or not Thermal Grizzly Conductonaut is more efficient in a small form factor laptop such as this one than a traditional thermal paste. What we have here is a Clevo 960 ED featuring an i7 A750H as well as an RTX 2060. So what we will be doing in order to test this is I will be running a slew of tests before and after applying the Thermal Grizzly. The tests I will be using will be Unigine Heaven as well as Blender. I'm going to be doing both a short burst test and a long use test. To accomplish this in Blender, I will be using the included BMW benchmark, which runs for roughly 5 minutes depending on the system, as well as the production benchmark that runs roughly for an hour. To accomplish this in Heaven, I will be both starting it from cold and doing the benchmark immediately. I will also be leaving Heaven run until the temperature stabilizes and then running the benchmark then. In order to ensure that thermals are the only limitation, I will be using Intel's XTU program to remove the power limitations for the CPU, and the GPU will be left as is. So I'm back a couple days later. We ran all the tests. I've compiled the averages out of 3 runs for each test. And essentially what it came down to is it didn't make much of a difference. Most of the temperatures and clock speeds fell within the margin of error, which I would consider to about 1 to 1.5%. The only notable difference was in short-term GPU testing. The GPU core temperature dropped from 68 to 65.8 C with the Conductonaut applied, which is a difference of about 3.5%, while gaining 10 megahertz on the core. Other than that, it was pretty much a wash. So what we can take away from this is that the heatsink in this laptop is too small to take advantage of the Conductonaut. Conductonaut is more proven in extreme scenarios like with processor delidding and water cooling, where you can see differences as great as 10 to 15 degrees Celsius when you're really pushing it. But it's not doing it in this. So not really worth it when you consider that the application process is much more difficult. In this situation, I had to take extra steps to put RTV around it just because there were concerns that it could leak out. Also cost, it's about twice as much as traditional thermal paste. So end of the day, it's a lot of effort for no benefit. Would be interesting to see with maybe like a beefier heatsink. Maybe we might see more differences in the short-term testings at the very least, maybe not the long-term, but this laptop in particular, not much of a difference. Special thanks to Adam, aka ADubs, for making this special order and allowing us the time to do the testing. If you have any unconventional requests for your order or any ideas for future videos, please let us know. Subscribe to us here on YouTube, follow us on Facebook, Twitter, Twitch, and we'll see you around, guys. Thanks for watching.